Corporate finance practice problem using OneNote. We're going to be using the present value and future value of annuity calculations to estimate college saving plan, one in which we have a current savings plan set up, and then there's an adjustment to it that we will have to account for to reach our goals. Get ready. It's time to take your chance with corporate finance. Here we are in OneNote. If you have access to OneNote and would like to follow along, you're not required to, but if you would like to, we're in the tab or icon on the left-hand side, the Practice Problems tab, and then down here in the 956 PV and FV of Annuity College Savings Plan Adjustment section. Also note that when using OneNote, you might want to look at the immersive reader. Most of our presentation files up top will also be mirrored down here with the same numbers in the text files being transcripts that can be translated into multiple different languages and both listened to as well as read in those languages, that being a good complement thereby to the practice problems up top to the presentations. Closing this back up, we're going to have our information up top. We'll use that information to calculate down below. Like with prior problems of a similar nature, we will do each of the calculations multiple different ways. If you would like to jump forward in the practice problem to go through it more quickly, just looking at one way we do each calculation, feel free to do so. So we're going to have our scenario up top. We have a college savings type of plan. This is a very typical type of situation. You're saving for college at some point in the future, either for yourself or for somebody else, and you're trying to come up with a savings plan to do so. And we're also going to have an adjustment. We're saying, hey, we started a savings plan. Now we need to make an adjustment to it. So we're going to say that there's a cost per year for the college. We're going to say is the $40,000. And we're going to say that the college will be 4 years. So we're going to assume 4 years of college at the $40,000. College is going to start in 5 years. So we have 5 years to get to that $40,000 per year. And then we also have started saving in the past. So we thought about this in the past. We're imagining we put in and started to put in $5,400 per year for 5 years up until this point in time at a rate of 9%. We're going to assume that this annuity that already had been going for 5 years will continue to keep going until the college start date, which is still 5 years from today. We're going to be using the interest rate of the 9% or the rate at 9% with basically all of our calculations. So goal then is going to be, we want to first think about what the total cost is, and we're going to basically estimate the current value of the cost at the starting point of the college, meaning we're going to have to do an annuity for this $40,000 for the 4 years, bringing it back basically to the starting point of the college point in time, which is 5 years from today. So we'll have to do that annuity for 4 periods. And then we want to think about how much we're going to have saved up at that point in time, given our current plan, which is putting the $5,400 both in the 5 years prior to this, as well as 5 years continuing on. So we're going to have a calculation of this $5,400 that we want to project out into the future to see how much it will be at as of the point in time that the college starts. We can compare that then to what we have for the cost of the college as we present value it to that same starting point, which is going to be 5 years from today. And then whatever money we still need to be putting in, we can see if we're still short, which we will be in our practice problem. Then we can think about, okay, we have 5 years now. How much payments could we put in for the next 5 years so that we can accumulate up to the amount that will be needed for the college? So that's going to be our scenario. So if we go back down, first we got to do the annuity then for the college. I need to bring this 4 years at $40,000 back to the starting point of the college, which isn't the present day. That's going to be 5 years from today, but that's the starting point of the annuity basically related to the 4-year college. So that is, we're going to use the present value calculation, present value of an annuity. We'll do this multiple different ways. A formula would be P times 1 minus 1 plus R to the negative N over R. And the P is going to be the 40,000 times 1 minus 1 plus R, rate 9%, to the negative N. That's going to be the 4 years for the college divided by R, once again, 9%. We're going to break that out into our kind of table format down here. So we're going to put the payment on the right-hand side, and then we'll break out the numerator into the middle here. So we're going to say 1 And then I'm going to break out this 1 plus r to the negative n. There's the 1. The rate is going to be the 9%. That's going to be 109%. And then we'll pick up the number of periods, which is going to be 4 years, negative n. We're going to get this number down below. Let's plug this into our calculator just to practice going to the power of 4. We do need a special calculator to do that. So I'm going to go to the drop down and get a scientific calculator to do this scientific like. So we're going to say this is going to be 1 plus the 0.09. That's going to give us 1.09. We're going to take that to the power of 4, but I need to make that negative. So it's caret 4, and then I hit the little negative down here, negative 4. And there we have it. So there's the 7 or 0.70842 and so on and so forth, subtracting then the 1. So minus 1, and that's going to give us then this 0.2915 and so on. And that's going to be the numerator. Then we bring in the denominator, which is going to be 9%. So I'll take that amount and divide it by the 9.09, or 9%, gives us 3.2397 and so on. Finally, we could take that and multiply it. We have these two components now times the 40,000. Taking that times 40,000 gives us the 588.80 about. I'm going to convert my calculator back to the normal calculator, standard calculator, not being quite as scientific-y. And so there we have it. So as of the starting point of the college, which is 5 years from today, present value in the 4 years, we need $129,588.80. So now, next step would be, we've been putting money in. Where will this annuity be as of the starting point? Then we can compare and contrast that to the money we will need, and then figure out how much more we might need to put into another annuity for 5 years to reach the goal for the college. Before we get there, however, and you can jump forward if you would like to, we're going to do this calculation a few different ways, a few more times. The next way you might see it, I'll scroll down here first, most likely is with Excel. Excel is the next way you might do it, or a financial calculator. This would be the fastest way to do it. We would do the good old present value calculation. It would be the rate being the 9%. The number of periods would be 4, because we're talking 4-year college. And then we're going to pick up the payment, which would be then the $40,000. That then giving us, once again, the $129,588.80. Most likely, once again, the fastest way to do it would be the Excel calculation down here. We could also do a running balance type of calculation, present valuing the annuity. So remember, anytime you look at an annuity, you could think of it as a present value of 1. In this case, 4 present value of 1 calculations. Remember, as we do this, we're not bringing it back to the current day, however. We're bringing it back to the starting point of when college is going to start, and that's in the future, 5 years into the future. But we're bringing back that 4-year annuity, 4 years of college, to the starting point. So we could then take this and say, okay, that first $40,000 payment, if I was to present value it as 1, I won't do the calculation right here, but you can use Excel basically to do that, and we can present value each one of the payments back. That would be the $36,697. If we did year 2, present valuing the second $40,000 payment, which would be 2 periods out, back, that would be $33,667. Adding to the $36,697 gives us the $70,364. Year 3, once again, $40,000 present valued 3 years back, $30,887, and so on. That then also getting us to about, because it's rounded, pennies have been taken away, $129,589. Another way we can calculate that first component, and finally we can do it then, of course, with the tables, which is always an exciting and fulfilling way to do that. So that's going to be 9% and 4. We're looking 9 and 4, 9 and 4, 9 and 4. And that's going to be then 3.2397, making sure that you got the proper table. This is a present value annuity table. Our editors down here always put the proper table down there for us, so that's nice. So we've got the 9 and 4, the 3.2397. There it is, 40,000 times 3.2397 gives us the 129,588, close but not exact to what we had up top, the 129,588.80, due to rounding, tables rounded then to 4 digits. Now we can do the second component here. So we've been starting to put money into college, $5,400 for the last 5 years. We're going to continue to do that at the 9% up until the starting point of college, which means 5 more years from this point in time. Where will we be? Will we have enough money to get to basically this amount? If not, which we won't in our practice problem, how much more do we need to be putting in per year for the next 5 years to get there? Okay, so now we got to do this one. This is what we've been doing thus far. So this is going to be a future value of an annuity calculation. Where will we be if we keep doing this for the whole time, which is 10 periods in total, 5 more periods from now, at that point in time that college is going to start? This is going to be the future value equals P. The payment is going to be the 5,400 times 1 plus R, R being the 9% to the power of the number of periods. Now we're going to be taking the full periods, which is 10 for the annuity. 5 have already passed, but it's going to be 10 in total. So we're going to take 10 periods here, minus 1 over R, once again, 9%. We'll break this out into a table type of format, similar to what we saw last time. P is going to be in the outer column, the 5,004. We'll then bring inside the 1 plus R to the N. So 1 plus R, which is 9%, 109%. If we add 1 and 9% to the power of 10, so 109, I won't do it with the trusty calculator again, but to the power of 10, you need the scientific calculator to do that, remember. That's going to be the 2.3673 and so on. And then we're going to take out the 1. That's going to be the last part of the numerator, getting us to the 1.367365. Then the denominator being R. R is once again 9%. Numerator divided by the denominator is going to give us that 15.1929 and so on. Finally, multiplying the 5,004 times the 15.1929 and so on gives us the 82,041.82. So this is where we're going to be as of the point in time that we're going to have to start spending this money. And so if we compare that to what we present value the 4 payments of the college to the point in time that the college starts at the 129,588.80, we're short. The 129,588.80 minus the 82,041.82 means we need another 47,546.97 to meet our goal, and we have 5 years to get there. So how much would we have to put in yearly in order to meet that added shortfall that we have? That's going to be the third part, but we're not going to get there yet because we're going to redo this calculation multiple times. If you want to jump to the third part, you can, of course, do so. We're looking for the payment of basically an annuity to get to that point. So then we're going to go down again, do this again. Now we could do this. Let's do it with Excel first. Excel's probably the next way that you would do this calculation in practice, the easiest way to do in practice. We'd say, all right, we're going to do a future value. It's going to be the rate. It's going to be that 9%. The number of periods is going to be 10 because 5 and 5 here for the full amount of the annuity. And then comma the payment, then that 5,004 giving us that 82,041.82. That would be the fastest way to do it in practice, most likely the thing that you would want to use in practice. We can also do a running balance calculation. This could be done in practice as well, just to give us a better idea of what actually is happening. So we could say the number of periods, if I had that 5,400 and we just calculate how it grows, and we can watch it grow, which is good times. Watch the money grow. We're going to go 5,400 times 0.09. That's going to give us 486. And if I add that to the payment that we're going to put in payment 2, 5400, plus the prior payment we had last time, 5400, we're going to get the 11,260. If we take that 11,260 and we multiply that times, once again, times 0.09, we get the 1016 about. Adding the payment we're going to put in there, 5400, plus where we were at last time, the 11286, it grows to 17,702. And then we could do that again and say that's going to be times 0.09. And there that. And then I'm going to add that to the payment we're going to put in, 5,400 again, plus the prior balance, 17,702. We get the 24,695, and so on and so forth. And we can watch it grow down to the 82,042. So that's another way we can do it. Tedious to do with a calculator. easy to do in Excel, could give you a better idea of what is actually happening as we see the running balance and our money grow. So then we can do it with tables down here, of course, and that is a good way to do it. So we can say that we have the 9% and 10, making sure that we're picking up the proper table down here. So we got the 9% and 10, 9 and 10. We got the 15.193. So there's the 15.193 times the 4,500 of the payment gives us the 82,042.20, close to, not exact as, the 82,041.87 we got before. Why? Rounding, tables rounded to 3 to 4 digits, it looks like, down here. Okay, final part. We get to do the final part now. We had that shortfall. We saw that we had the shortfall of we need another 47,546.97. We got 5 years to get there before the college starts. So we're going to say now, how much do we have to put in per year to get to fill that shortfall so that we don't have a shortfall and everything will work the way it's supposed to. So to do that, we could do a future value of an annuity. We can also use a payment kind of calculation within Excel. We'll show that shortly, but note we're working with the future value kind of calculations. If you were doing this mathematically, method 1, use future value calculation, solving not for the future value, but for P, that would be the unknown. We're not going to use a new calculation, a new formula. We're going to plug what we know into the same formula, solve for the unknown. So the future value is what we know. That's going to be the 47,546.97. And then that would equal P, what we don't know, times 1 plus R, 9%, to the number of periods, which would be 5 more years till the college time, minus 1 over the 9%. Then we can solve for P, that being the unknown. I won't do the algebra here. You can do the algebra. I will put this formula back into our worksheet down below, not reworking it to solve for P, but rather solving for the future value of the annuity as we've seen normally, and then think about how we can use a tool such as GoalSeek to back into the unknown in that format, and we can use Excel then to do that. We'll apply that concept then to the formulas as well. So this amount up top, we're going to put the P on the right hand side. This would be the unknown. So in our thought process, where we would put something, this is the answer, but we would put something as a placeholder there, like $1,000. Calculate the rest of it with that in place. So we've got the 1 plus the 9%, 109% to the power of number of periods, 5. So it would be the 109% caret 5 to the power of 5, giving us the 1.538624 minus 1, and that would be the ender of the numerator. That gives us this number, the 0.538624, and then the denominator, R divided by R, which would be 9%, giving us the 5.9847, and so on, multiplying then the outer column out. That then gives us here the answer, but if we didn't have the correct number up top in this cell, if I just had 1,000 in there, for example, we can imagine we could use trial and error in this method to add it to 2,000, 3,000, and so on until we get the end number to what we know it's going to be. So rather than using algebra to rework the equation, we're simply going to use the same equation and then find what fits into the unknown. Difficult to do with a calculator, or tedious to do with a calculator, if not difficult. Easy to do with Excel because we can use GoalSeek to, in essence, do that. That same concept then can be used down here if you know the functions in Excel. So if I'm using the functions in Excel, so the function we might know is the future value of an annuity. And if I plug that in, I'm looking for the unknown here, the payment, which is not the end result of the function. I can't rework the function algebraically the same way as I can with an algebraic equation. I could look for another function which has this unknown, so that the result would be that unknown. We do have that. That would be the payment function. But you can also use GoalSeek in this fashion as well, and it's useful to have that concept in mind when you're using Excel functions. If you're saying, hey, I know this function, I know everything fits, but the unknown isn't the end result, you can kind of use GoalSeek to back into it. So that method would be similar. We would say it would be the future value times the rate, 9%, comma, number of periods, 5, comma, and then the payment, which is going to be the amount that we do not know which we can plug into another cell that we plan on changing with the help and use of GoalSeek. Then once we get the result of this formula, we can tell Excel, please change the end result, this number, to be what we know it should be by then changing the factor that we don't know, and it will then use trial and error to find the factor that we do not know. That's one way you can use a function in Excel to find an unknown other than the end result of the function. Or you can look in the function and say, hey, look, there's a payment here. Is there another function that basically reworks the function so that it solves for the payment? That would be the payment formula down here. And you could plug it here. This would be the most direct way to find what you're looking for. That would be the payment. That would be the rate, 5%. Number of periods, 5. Not the present value, so that's a comma, comma. And then the future value is going to be, once again, that 47,546.97, giving us that 7944.74 we would have to put in each year if with assuming the rate of 9% in order to achieve what we need to fill the gap to make sure we have enough to pay for the college fund. Okay, we can also do this with a running balance kind of system, of course. We can I won't do a GoalSeek method, but just note that if you have and calculate the payment, then you can think about how the payment would grow and just plug this into Excel. This could be a good double check that things are working the way you understand them, meaning you could plug it into Excel, 7945. If I put that in times 0.09%, that would be 715 about. And then if I put another 7945 in plus the prior 7945, that gives us the 16605. And then in period 3, if I say take that amount times 0.09, we get the 1494 plus, if I put in another 7945 plus the prior balance 16605, we get to the 2644 and so on till we get to the ending balance, that 47,547. That then, of course, the amount that we wanted to get to, that's our shortfall that we were aiming at. So this could be a method you could use to then, once calculating this way, you may not have complete confidence with Excel, right? They just magically gave you this number, and then plug it back into a table, which is easy to work in Excel so that you understand it, right? You can run this running balance table quite easily and get to the same ending balance and be able to understand possibly a little bit easier and better understanding of what's going on to get to that ending balance. Then scrolling down, we can also do this, of course, with the tables, but this time we're kind of backing into the yellow number. This is what we do not know. We know the ending balance, that 47,546.97, that's what we want to get to, and we can't find the amount on the table because it's 5 and 9 or 9 and 5, 9 and 5, 5.9847. So then we can back into this number. In other words, usually it would be the payment times the table amount gives us the ending result. This time we got the ending result, 47,546.97 divided by the table amount, 5.9847, gives us, one more time, hold on a second, 47,546.97 divided by the table amount, 5.9847, gives us the, I got to maximize my calculator here so it can see it properly. So if I maximize my calculator, there it is. So there's the 7944.75. And so on. So there's multiple ways that we can do it, and that number possibly is slightly different than what we got up top due to rounding of the tables for 4 digits, tables rounding then to 4 digits.